Hi everyone, I am Joy. I'm a PhD student at North Carolina State University. My advisor is Dr. Tim Menzies. Today I am going to present my FSE 2020 research track paper, Fairway, a way to build fair ML software. You can follow this link for following the slides. Okay, this is a brief roadmap of my talk. First, I will give introduction about ML software fairness. I will talk about human bias. Then I will give you some background about previous works and dataset. Finally, I talk about my strategy Fairway, which combines two procedures. First is pre-processing and second is model optimization. Talk about the results I achieved in the form of research questions, then the conclusion and question answer. So what is ML software? Nowadays, almost every software uses some kind of machine learning model inside it. If a software uses machine learning model, it is called ML software. In 2019, a Microsoft paper came out and they talked about 9 stages of the ML software workflow. It starts with model requirement, then data collection, data cleaning, data labeling, feature engineering, model training, model evaluation, deployment, and monitoring. Here we have shown the arrow where our method Fairway will come handy. Now some applications of this ML software. Here we see that instead of using human beings in case of banks for credit card approval or loan application, a machine learning model evaluates an application and decides whether the candidate will get loan or not. Another example is criminal sentencing. In case of Wisconsin Supreme Court, there was a model which used to determine the likelihood of a person to occur crime in future, and based on that likelihood, the judge used to take the decision. So software is making critical decisions which are very crucial in society. But are these software always fair? No. There are certain cases where we see that software shows some kind of discrimination. Here we are showing 3 such examples. First, take an example from Google Translate. We are writing he is a nurse, she is an engineer in English, then translating to Turkish. And when you do the reverse from Turkish to English, it's becoming she is a nurse, he is an engineer. So initially he was nurse, she was engineer, but now she is a nurse, he is an engineer. So you can see Google Translate is showing gender bias. The second example is a facial recognition algorithm where a dark-skinned lady is trying to recognize her face, but she could not. When she is putting a white mask on her face, then the algorithm can find her face. So that's a racial bias we can see in this face recognition algorithm. The third is a loan program where there are 4 features: income, savings, age, and race. If the model uses savings as an important feature, then it's okay, it's fair. But if it somehow depends on race, then we can say that model is not ethically correct. So these are the scenarios where I can see that though machine learning models are used in critical applications, but in some cases they are showing some kind of bias. Now, the second example is we said about criminal sentencing, right? The machine learning model was used, but that was found highly biased against African Americans. So software shows discrimination in certain cases. Now, not only software, we human beings are also some kind of biased. Look at this example of Fortune 500 companies in 2017. The above 2 graphs are for senior managers and CEOs. We can see only 20.5% are senior managers are women. For CEOs, it's only 6.4%. But these decisions were not made by any software. These were made by the top leadership of the company. So they were human beings, but still they showed gender bias in case of their decision. And look at the bar chart. Here we can see for senior executives, 73% people were white and rest were only 27%. So we can see human decisions are also sometimes gender biased or racial biased. So the important takeaway of this slide is that if we take this data as a training data for machine learning model, which is already biased, then the machine learning model will have a high probability to be biased because the training data is biased where ground truth is biased. So that's the main takeaway from this slide. So what's the research problem we are going to deal with here? ML software in some cases shows discrimination based on some ethical or sensitive attributes like sex, race, age. Detection of bias and removal of bias from ML software is necessary. Finding the cause of bias cannot be ignored, and human bias may get injected into the training data. As a result, we propose a method Fairway, which finds, explains, and removes bias from training data and trained classification model. Here we are using only tabular data. If level was done by human reviewers, it leads to finding bias in human decisions. Our method Fairway is model agnostic and it is adjustable. The next part is background. Okay, so before jumping into the solution, we first need to give the basic terminology of fairness domain. Here we are using binary classification models and tabular data. In each data set, there are some attribute columns and a class level column, which is binary. So there are only two values. A class level is called favorable level if the value corresponds to an outcome that gives advantage to the receiver, like being hired for a job or receiving a loan. Now, in every data set, there are one or more than one, maybe two attribute, which are called protected attribute, that divides the population where the difference in terms of benefits are different. And such example is sex or race. Group fairness is the goal. Based on the protected attribute, both the groups, privileged and unprivileged groups, will be treated similarly. Individual fairness is the goal of similar individuals will receive similar outcomes. Now previous work, what previous researchers have already done. Our previous work can be divided into two segments. The first one is finding the bias, second one is reducing the bias. So this is the finding bias. There are mainly three major works. First one is Themis, second one is Aquitas, and the third one is black box fairness testing. They are all test case generation algorithms. They try to find bias in a trained model outcome. We did not use this method. Instead, we decided to use our own developed method based on situation testing. What is situation testing? I will tell it later. And we found that our method is way faster than previous methods. And so the main takeaway from this slide is these previous algorithms only find bias in the model. They don't find bias in the data. We figured out that our method situation testing can find bias in the training data. So they find bias, we find cause. In case of removing bias, there are mainly three types of work depending on where you use the bias mitigation strategy. First one is pre-processing, where you pre-process the data before training the model. Second one is in-processing, where you divide the data set into three parts: train, validation, and test set. First you train the model, then on the validation set you optimize your model, and finally the optimized model is used in the test data. And the last one is post-processing, where after the model is trained, while predicting, you change the class levels to reduce the discrimination after classification. Our method Fairway is a combination of pre-processing and in-processing approach. The fairness measures we used, that's we are describing here. We used two fairness measures: equal opportunity difference, that is EOD, and average odds difference, that is AOD. We selected these two metrics which were highly cited in IBM AI F360 repo. So the definition of this is EOD is the true positive rate difference between unprivileged group and privileged group, and AOD is the average of FPR difference between these two groups and TPR difference between these two groups. If you want to know about these fairness measures, please do read our paper. These are the 5 datasets we used. All 5 are binary classification datasets. We got these datasets from UCI ML repository, and all of these are very common in fairness domain. One is adult census income, Compass, German credit data, default credit, heart health. And we used logistic regression model for the binary classification. Now we are finally moving to our strategy, Fairway. Fairway combines two stages. First one is pre-processing, second one is optimization. If you look at the diagram, we are dividing the data set into 3 parts: 70% for training, 15% for validation, and 15% for testing. First, we are doing pre-processing on the training data set to remove the biased data points. And then after removal of biased data points from the training data, we are training logistic regression model on the trained data. And then we are using fair flash algorithm with 4 goals: recall, false alarm, AOD, and EOD, to find the best parameters of the model. After we get the best parameter, then we tune the model, and with the tuned model, we are doing prediction on the test set. Now, first step, what is pre-processing? Here we are dividing the training data into two batch, depending on the value of protected attribute. Suppose the protected attribute is gender, so we are dividing the training data into male and female, and we are training two separate models on those two groups. Now, for each data point in the training data, we are checking the outcome of these two models. If they match, we are keeping it because this is a fair data point. But if they don't match, we are removing that data point from training data. Thus, we are shrinking our training data into only those data points which are fair. And here we can see that at most we are losing 15.6%. So I think this is a fair magnitude for achieving fairness. So these are the last column indicates what percentage of training data we are losing because of this pre-processing step. And later we will show that does not affect the performance of the model much. The next step is multi-objective optimization to find the best parameters of the model. Now, why multi-objective? Prior works in fairness found out that fairness and performance of the model are competing goals. Look at the graph on the left-hand side. There are 4 algorithms: reweighting, reject option classification, adversarial devising, and optimized preprocessing. Whenever they are applied, the accuracy of the model are reducing from 0.82 to 0.68. So the fairness and performance, these are competing goals. So we can see when we have two objectives, objective A and objective B, where those are competing goals, we need to use the concept of Pareto frontier and Pareto optimality to find the trade-off between these two. So instead of using single objective, we use the concept of multi-objective optimization to find the best balance between the performance of the model and fairness of the model. We used SMO, which is the short form of sequential model optimization, to find the best parameters for logistic regression model. The concept of SMO is very simple, given what we already know about the problem, and depending on that, what should we do next? The first part is achieved by using a machine learning model, and the second part is performed by an acquisition function. Now, what are the goals of this multi-objective optimization? There are mainly 4 goals we used. 2 are for performance, recall and false alarm, and 2 are for fairness, AOD and EOD. Recall is TP divided by TP plus FN. False alarm is FP divided by FP plus TN. Recall is higher the better. False alarm and AOD and EOD are lower the better. Previously, we have already described what are AOD and EOD. If you want to know more, please read our paper. So these are the 4 objectives we are using. And the algorithm we are using is FairFlash. It's a sequential model optimization algorithm. We start with the training or validation data, and we build a learner with default parameters. Then, and each step, we find out best parameters depending on the 4 goals: higher recall, lower false alarm, lower AOD, and lower EOD. We continue this process until the stopping criteria is met. Finally, based on the validation data, we get the best parameters of the model, and we use that model to get the outcomes from the test data. So this is the concept of FairFlash, which is a 4-goal optimization strategy. The 4 goals are higher recall, lower false alarm, lower AOD, and lower EOD. Now we are moving to results. Our results are in form of 6 research questions. The first one is, why do you need this? Why can't we just use standard learners without any tuning? The second one is, how much pre-processing is helping? Third one is, how much optimization is helping? Fourth one, Fairway, which is a combination of RQ2 and RQ3. How much Fairway is helping? Next research question is, what's the performance of Fairway comparing to previous fairness algorithms? And last one is, can Fairway be used as a combined tool for detection and mitigation of bias? These graphs will give you the answer of RQ1, RQ2, RQ3, and RQ4. These are the graphs of recall, false alarm, AOD, and EOD. We know for recall, higher the better, and for rest of them, lower the better. So first one, yellow, is baseline. That is the default approach. We are doing no tuning. The second one is pre-processing, which is blue. The third one is green, which is optimization. And fourth one is Fairway, which is a combination of blue and green. So look at the recall chart. We are looking that Fairway is performing better than the optimization and pre-processing. So we are getting high recalls for the red bars. For false alarm, Fairway is doing good. And look at AOD and EOD. Fairway is doing significantly better than just pre-processing and optimization, because we see very low bars for red ones. So the takeaway from this slide is Fairway can significantly reduce bias AOD and EOD, and also keep the performance of the model almost same in most of the cases. So the first 4 research questions, what is the answer? We cannot use standard learner because that the yellow line was not very good. And for RQ2, RQ3, and RQ4, all of them are performing well, but Fairway is performing better than only pre-processing or only optimization. Now the 5th question is how Fairway is doing better, how Fairway comparing with previous algorithms. Now here we are showing the comparison with 4 previous highly cited algorithms: optimized preprocessing, reweighing, adversarial debiasing, and reject option classification. Here we are showing the change of recall, false alarm, AOD, and EOD for 3 datasets: adult, compass, and German. Here, black means damage, which is bad, and gray means improvement. So look at AOD and EOD. Almost all of the algorithms showing most of gray cells. That means they are significantly reducing the bias. But if you see recall and false alarm, most of the prior algorithms contain black cells. That means they are damaging the performance of the model. While in case of Fairway, look at the false alarm. Fairway is not reducing the false alarm, not increasing the false alarm that much. That means Fairway is better, is somehow better. We're keeping the performance of the model same while reducing the bias. So that's the main takeaway from this slide. So we got the answer for RQ5. Now moving to RQ6, whether Fairway can be used for a combined tool for detection and mitigation of bias. Yes, because in case of Fairway, we already told in pre-processing, we find out which data points in the training data are biased and we remove those. Here we use the concept of situation testing. Situation testing is you just change the predicted attribute value to see whether your model prediction changes or not. Suppose there is a male data point, you just change the gender attribute to female and check the model prediction whether it remains same or not. If it remains same, then means that your model prediction is fair. If it's not, your model prediction is not fair on that data point. So we did that for the entire training data, and we found out that Fairway can significantly reduce the number of biased data points in the training data. Yellow one was the default and blue ones is the after. You can see that blue bars are way lower than yellow. So Fairway can be used to find biased data points in the training data, and also we have shown that it can be used to reduce bias in model outcomes. So it can definitely be used as a combined tool for finding and mitigating. So we got the answer of RQ6. The answer is yes. Now, finally, what's the additional contributions of Fairway? That Fairway can find biased data points which have improper labels in the training data. And if labeling was done by human reviewers, we can find out bias in human decisions. So this is called ground truth bias. Next one is Fairway is model agnostic. Here we used a regression model, but the same approach can be used for any other classification model. The next one is it's a combination of pre-processing and in-processing. So practitioner can choose which one he or she needs to use, whether only pre-processing or only in-processing or the combination of both. Last one, and then the next one is adjustable. You can select which parameter to tune. And Fairway is a combination of finding and removing bias from training data and model both. That's all. Now I am open for question and answers. Thanks for attending my talk.